Okay, so a really exciting, important, I mean, really, well, hopefully exciting video on solving two-step equations using balance method. So you hopefully would have seen myself on one-step equations. This is kind of following on, but really important that we properly understand balance method, particularly as we're now going from one step to two step, and then later on we go up to three-step and four-step equations. Anyway, without further ado, we saw previously that if we were given a statement like this, which was I'm thinking of a number, which we could show by x, I multiply it by 2, so 2x, I then add 3, okay, we would write it like this, and if it's equal to a number like 25, we would write it like this. And it is two-step because you had x, you did one step, and then two steps to get to your number. And we're looking at solving equations like this today, so finding this missing value by using balance method and properly understanding it. So let's get into it. Okay, we're looking at solving this so looking at finding the missing variable by using this beautiful thing, balance method. It's really, really important. Okay, so again, the same equation. I want to solve this equation. Right, I want to find the missing x variable. I want to get x to be equal to something on its own. I'm going to consider this using our scale analogy. So we're saying that the left-hand side of the equation, 2x plus 3, is equal in weight to the right-hand side, 25. So currently, right, the left-hand side, 2x plus 3, has the same weight, is equal in value to 25. Everything is in balance, which is good. Now, we know from the previous videos that when you solve an equation, it is like untying a knot. So you do the opposite to how you tied the knot, which is why it's really important you understand how the equation was formed. So we know, right, if we consider 2x plus 3, we're pretty good now, hopefully, from the whiteboard stuff, at knowing we started with some variable x. We then multiplied it by 2 to give you 2x, and then we added 3 to give you 2x plus 3. And this is really important. We did not start with x. We did not add 3, and then we didn't go and times it by 2. Because if we did that, we'd have x plus 3, and then you would times everything by 2 to give you this, which is not the same thing as this. It's very, very different, which is why the previous video was really, really important. The order here is crucial. Anyway, solving means we do the opposite to how we tied the knot. So we've got to this, 2x plus 3. Solving, we do the reverse of this. So the opposite of adding 3, okay, the opposite of addition is to take away. So we take away 3, and then we divide by 2 to get back to x, to get x equal to the thing on its own. And again, right, the opposite of timesing by 2, opposite of timesing is to divide. So with this equation here, right, everything's in balance. I want to solve it. I want to begin with this and go back by initially taking away 3. So I can take away 3 from this. But we know from the previous videos, right, if I take away 3 here, bam, the scales are unbalanced. This is not good. So we've got to go and take away 3 from also the 25 to get the scales back in balance. This is absolutely crucial. Okay? With an equation, you must do the same thing to both the left-hand side and the right-hand side. So I've done the taking away 3 part, first of all. Continuing on, okay? I've got this up here just to remind us what's going on. The whole point of taking away 3 here is because, well, the opposite of adding 3 is to take away 3. So they're going to cancel, they disappear, they make 0. Okay, so then we go and get these 3's disappear. You're left over on that left-hand side of the equation with 2x being equal to 25 take away 3, which is 22. Which is lovely, but I haven't solved the equation. I've got 2x. When you solve the equation, you want to get x back on its own. So I've got 2x is equal to 22. But I've done the first part. I've taken away 3 successfully to get me to the 2x part, which is here. I've now got to go and divide by 2, because the opposite of timesing by 2 is to divide by 2. So I go and divide this by 2. But what's going to happen now? Bam, the scales are unbalanced. This is not good. We know you must do the same thing to both sides of the equation to keep it in balance. So I've got to divide the 22 also by 2. And the whole point of dividing by 2 here was because the inverse of timesing by 2 is dividing by 2. So it gets you back just to x. They cancel out. They disappear. So you're left over with x over here, which is really, really good. So you've got x being equal to 22 divided by 2, which is 11. We are finished. You've solved the equation. You've got x being equal to some value on its own. We can check this. The beautiful thing with solving equations is you can always check your solutions. Right, so x is 11. We've got 2 times your x value 11, which is 22, plus 3 is 25. Superb. We've got our solution. Okay, let's look at a second question, which is x take away 4 divided by 2 equals to 7. And let's, again, consider this using our scales. So we're currently saying the left-hand side, this part over here, right, x take away 4 all divided by 2 is equal to, it's in balance with 7. And again, when we consider, right, because now you might be saying, well, I go and plus 4 to both sides, or I might go and times by 2. Like, we've got to understand the order. It's really important. So when the equation was formed, when x take away 4 divided by 2 was formed, okay, we need to understand the order here. So initially, right, we started off with x. We then took away 4 to give us x take away 4. We then divided the whole thing by 2 to give us this, which is very different to doing this. If you wrote x, if you divided it by 2, first of all, you would get this, x divided by 2. If you then took away 4, you would get x divided by 2, take away 4, which is not the same thing as this, which is why on the previous video, I spent a lot of time going through understanding the order of stuff. Now, when you solve something, you do the opposite to how it was formed. So we're at this stage. When you solve it, you want to do the opposite. So the opposite of dividing by 2 is the times by 2. Again, division and multiplication are opposite. Because effectively, right, dividing by 2 and timesing by 2 is going to cancel out this part down here to get us back to over here. Now we've got x take away 4, and the opposite, the inverse of taking away 4, is going to be to add 4, because take away 4 plus 4, they will cancel to get you back to x. So looking at our scale over here, the first step when we solve this is to times this by 2. There we go. But what's the issue here again? The issue is the scales are unbalanced, because you've got to do the same thing to both sides of the equation. So I go and times also the 7 by 2, so I'm back in balance, okay? And if we continue over here, the whole point of timesing by 2 here, by doing this section, is to cancel out the 2's, to leave me with x take away 4. So I've done this part, I'm at this stage, it's a tick, sorry, there we go. So I'm left over, the 2's disappear, I've got this part left over, x take away 4, which is good, and 7 times 2 is equal to 14. Have I solved the equation? No, because I've got x take away 4, I've got to have x on its own, which currently is not the case. I've got x take away 4, I'm here. I've got to get rid of that minus 4. I do that by adding 4 to this. There we go. Because that's going to get me back to x, which is good. But what happens here? Unbalanced. You must do the same thing to both sides. I must add 4 to the 14 to keep things back in balance, which is good. Now, the negative 4 and the plus 4, they're going to cancel, which is good. That's the aim of the game here. They disappear, which is good. So I'm left over now with just x being equal to 14 plus 4, which is equal to 18. Beautiful. I've solved the equation. I found my x value on its own being equal to 18. And again, the beautiful thing about solving equations, we can check our solutions. If x is equal to 18, I've got 18 take away 4, which is 14 divided by 2 is 7. So I know that x equal to 18 is definitely correct. Okay, wow. So now we're going to look at using this in practice, because in reality, we wouldn't go and draw out a load of scales and all this stuff. We'd be there all day. Okay, so we're going to look at just how we do this and show our work in practice. So I want to solve the following two-step equations. I've got 2x take away 5 equals to 21 to begin with. Now, the issue here is if students don't understand how the equation was formed, they might say, well, let's just go and divide everything by 2 because, you know, I'm timesing by 2 here. But that wouldn't work, unfortunately. So it's really important that you understand. And the more you do of these, the quicker you can just do it in your head. But you've got to understand that this was formed by having x. You then timesed it. You then multiplied by 2 to get you to 2x, which is here. You then took away 5 to get you to 2x, take away 5. The order is really, really important. If you took away 5 and times by 2, you would not get this, as we saw on the previous video. Okay? So again, we know that to solve an equation, we go backwards, right? We do the opposite to how it was formed. So to go back now from this to x take away 5, we've got to do the opposite of taking away 5, which is to plus 5 to begin with. And you've got to do that to both sides to keep everything in balance. And this is good because the take away 5 and the plus 5, they're going to cancel. So it would be the wrong choice to divide by 2 to begin with. Okay, and then what's left over? On my left-hand side over here, well, the 5s have gone. You've got a 2x left over. So you've got 2x being equal to 21 add 5, which is equal to 26. Am I finished? No. Solve means I want to get the missing variable, which in this case is x on its own. I've got 2 times x equals 26. So now, right, I'm at the 2x point. I want to go back to x. The opposite of timesing by 2, because I'm untying the knot, the opposite of timesing by 2, because that's 2 times x, is to divide by 2. To divide by 2. Scales are unbalanced. Same thing on this side. Back in balance. Divide everything by 2. And this is good, because now this is going to cancel. And you're left over with your x, which is good. So you get x being equal to 26 divided by 2, which is 13. And that is your solution. Let's highlight it. There we go. And we can check our work by putting it back into the equation. Right, we've got 2 times your x value, which is 13. Take away 5, well, 2 times 13 is 26. Take away 5, indeed, is 21. So you know that is correct. Just to make it really, really clear, right, the order is so important here. If we said we began with x, and if you said, well, you take away 5 first, so if we said, right, you go and take away 5, that would get you to x take away 5, okay? And then, if you said, well, now we times it by 2, we times this by 2, so we times it by 2, that would give you 2 times everything here. This is not the same as this, which is why you've got to understand the order in which the equation was formed. Yeah, and the more you do of these, the quicker you can just do it in your head, and the more you just recognise what is going on. Question B. We've got solve this equation. 3 bracket x plus 1 is equal to 15. Again, you've got to think, how was this equation formed? Right, so we must have began with x, okay? If you're not sure, let's go through it. If you think, well, you then times x by 3. So if you then thought, well, we then times x by 3, well, that would get you to 3x, okay? Which is not looking too good, but we keep going anyway. And then you think, okay, then they added 1. So then we went and added 1 here. That would get you to 3x plus 1. This is not the same thing as this. So that is not how the equation was formed. So again, you've got to understand how it was formed. We begin with x, and actually we plus 1. We add 1 to that x to give you x plus 1. Okay, well, not very neat. So there we go. And then from here, we times everything by 3. So we multiplied the whole thing by 3 to give you 3 bracket x plus 1. Okay, so there we go. And when you solve the equation, we now go back in this direction. So we're starting off here, 3 bracket x plus 1. The opposite of timesing by 3 is to divide by 3. So I divide the whole thing by 3. So I divide the whole left-hand side of the equals. So I divide this by 3, and I must, because now my scales are unbalanced, I must do the same thing and divide over here by 3. And the whole point of dividing by 3 here is these 3's, they cancel out, which leaves me, importantly, with x plus 1. So I've got x plus 1. I'm at this stage now, which is good, being equal to 15 divided by 3, which is 5. So I'm at x plus 1. Right, I want to get rid of this plus 1. What's the opposite of adding a 1? Taking away 1. So I now go and take away 1. Again, unbalanced. Other side, take away 1. What's going to happen here? These cancel. So I'm left over now with x, which is good. X being equal to 5 take away 1, which is equal to 4. And of course, we're going to go and check our answer now. So we've got pen. Let's make it in green. So I've got 3. Bracket my x value is 4, so 3 bracket 4 plus 1. Right, 4 plus 1 is 5. 3 times 5 indeed is equal to 15. So that's good. Right, that solution is definitely correct. Look, the more you do of these, you will just be able to sort of do it in your head, okay? But when you first see it, it does take a bit of practice. But trust me, this slower approach at the start, because often people just teach it right, you just learn to if you see this kind of equation to plus 5, but it's pointless. When you see difficult equations like this, x squared plus 3 divided by 4 take away 2 equals 2, right, if you understand how the equation was made, it becomes really easy, right? If you just learn a set process, you never think of how to do things. Anyway, Whew. Right, you can try these two questions here, these two your turns, and then that's going to be it for this video. Okay, so the first one, we've got solve the following equations, two-step equations. So we want to go and find this variable here. This equation is similar to the one on the left-hand side, so let's get into it. We've got 5y plus 3 equals to 23. So now maybe you're thinking, I had y, I times it by 5, I then added 3. Solving it, untying it. So I finished off by adding 3. I go backwards by taking away 3 to begin with, and I must do it on both sides to keep everything in balance. These cancel, which is good. You're left over with, over here, with 5y being equal to 23 take away 3, which is 20. You've got 5 times y equals 20. Well, what's the opposite of timesing by 5? It is to divide by 5, unbalanced, both sides, keep it in balance, divide it by 5, which is good. Okay, these guys are going to cancel, which is good. So you're left over with the y, which is good. Y being equal to 20 divided by 5, which is 4. And there we go, good. And we can, of course, check our solution by putting it back into the equation. We've got 5 times your y value, which is 4, plus 3, hopefully equals 23. 5 by 4 is 20, add 3 indeed is 23. So that's a good solution, correct. The second question, let's have a look. We've got 2 bracket x take away 3 equals to 30. And again, the more you do this, the quicker you get at it. Right, we have x, you have x. We then take away 3. We then times everything by 2. So the opposite, we go back the other way. We divide it by 2. We divide it by 2. We do times it by 2. What we're doing, we times it by 2. I have x, I take away 3, and then times everything by 2. Solving it, I untie the knot, I go backwards. So I begin now by dividing by 2. So I divide this by 2. Same on this side. Let's get rid of this, otherwise it gets a bit messy. Okay, and then what's going to happen over here is that these guys are going to cancel. Bam, which is good. I'm left over with x take away 3. So x take away 3 being equal to 30 divided by 2, which is 15. So I'm at x take away 3. Well, how do I get x on its own? What's the opposite of taking away 3? It is to add 3, unbalanced, both sides, add 3. I'm now almost back at my x value. They cancel. I'm left over with x being equal to 15 plus 3, which is 18. And that is my solution, because I've got the variable x on its own equal to something, and we can of course check it. Let's do that. If x is 18, I've got 2 bracket 18 take away 3. 18 take away 3 is 15. 2 times 15 equals to 30. Perfect. I'm correct with that. Okay, don't be disheartened if you didn't quite get it the first time, and I'm teaching it to a way which in the short term it is probably more difficult, but once you understand it in the long term, you're going to experience loads of success, and you can go on to do really hard stuff in Contrae, or which is different to just teaching it by a method, memorizing it, and not really having a clue what's going on. So as soon as it gets a little bit trickier, you're stuffed. So spend time and hopefully understanding this video. You can of course rewind it at any point you need to really understand it. Okay, thank you for watching.